Oh, hello again, and time for more amateur radio fun with VK6CS. I thought I'd give you a bit of an update on how the HF amplifier project's going. It's slow but sure. I've been doing some bits and pieces. Now this ABS box here is one of those things I had to have because I had to have DC fans. I didn't really want DC fans, but I'm stuck with DC fans. So I needed a power supply to run them. That's what these two toroidal transformers are doing. So the fan power supply is in this box, this red and black wire here. These red and black wires are going to go up and connect to the fans when the PA is actually bolted on top of this. But I thought, as I'm stuck with this ABS box, I'd build the bias arrangement in here as well. The grounded grid amplifier, the cathode bias arrangement. It needs a cathode bias arrangement rather, because it doesn't have a negative control grid supply. So I've got a big power FET there. That's going to be in series with the tube or the valve cathode, and that is going to set the cathode bias, the positive cathode bias, which is effectively setting the negative grid bias. I've got a power supply at the moment generating about 28 volts, and I've got a lamp, a little it's an ordinary car lamp over there, and you can see actually that's just glowing very dimly at the moment. That's in series with my FET there. Now I've also on my ABS box I fitted this post so that I can take the side off the amplifier and I can monitor the bias voltage, which is what this meter is doing at the moment, on this post, and I can also adjust it at this point here. Now this point here, there's a guide through the ABS box, and this screwdriver will literally just fall straight into the screw slot, so I can adjust the bias. And what that is part of a TO3 insulation kit. So there's a TO3 transistor insulation kit, and these come with an insulator which normally goes on each side. One goes through there, and the other one goes through there, and it's to keep the mounting bolts insulated from the chassis. But I thought, well, one of those would be ideal for my as a guide for my bias trim pot, my bias mini pot. So let's move that back a bit. I'll zoom in on that. There we go, there. So I can put that in there. When I put that in there, that falls into the slot, and I can adjust the conductivity of my lamp. So that's the voltage across the FET. With that much voltage across the FET, there's not very much voltage across the lamp, so the lamp is not illuminated. Now as I adjust that pot, I can control the brightness of that lamp with the FET quite happily, and as I turn that brightness up and down, so the voltage across the FET goes up and down. The higher the voltage, the dimmer the lamp, and the lower the voltage across the FET, the more voltage there is across the lamp, and the brighter it glows, like that. So I'll just set it so that there's, I don't know, there's probably about let's have about 12 volts across the lamp, something like that. So remember, this is a 24 volt power supply, maybe a bit more, so maybe even 28, 29 volts. So there's a similar sort of voltage to that across the lamp, and there's the lamp glowing there. Right, now I was talking to Al VK6KIF the other day on the Rolling Stone repeater, and he said, "Hey Steve, are you going to have an arrangement that shuts the valve off when the PTT is not pressed, or are you going to leave it sitting there idling?" So I thought, well, if that tube is just sitting there idling with no drive, there's probably going to be 100 milliamps of plate current, maybe 150 milliamps of plate current, so there could be, you know, 300 watts plus or minus of heat dissipation with the tube just sitting there doing nothing. And it would make sense to actually shut the valve off when it's not transmitting. So I thought, okay, well, I've fitted this this red wire here, and this red wire will go to my PTT activation relay. So I'm going to have a little activation relay so that when the PTT is pressed, the coil on that goes to ground. That relay will then activate the input and output relays, but that will be a single pole double throw relay. So what that will do is the common of my activation relay will go to chassis, 0 volts. This will go to the normally closed side, so when that activation relay is not activated, this red wire will be connected to 0 volts, and when the activation relay activates, it will swing over, this wire will then go open circuit, and it will make the other contact on the relay, which will energize the input and output relays. So this wire, when it goes to 0 volts, so at the moment the PTT is pressed, this wire is not connected to 0 volts. As soon as I release the PTT, this wire here goes to 0 volts and the lamp goes out. So that's the valve shutting off. So I press the PTT, this wire goes open circuit from the chassis, lamp comes on, so the tube comes on. As soon as I press the PTT, the contact relay that this wire is connected to goes open circuit with regard to as soon as I press the PTT, it goes open circuit, that's right. As soon as I release the PTT, the relay drops back to its non-energized state. This will go to the normally closed contact, so this will go to 0 volts and shut the valve off just like that. So that's how I'm going to shut the valve off when the PTT is released. So at the moment the PTT is released, press the PTT, there you go, valve goes away. Throbbing with watts. And release the PTT, that goes to 0 volts. Just like that. Okay, so there's a little bit of progress being made with the amplifier, and a little bit of a description on what I've got in mind with regard to shutting the tube off when there's no drive to it. Now I'll do a bit of a doodle on the whiteboard. I haven't done this for a while, so let's hope I can get it on the board and remember exactly what I'm doing. My deluxe red wire out of the way. Now, can I do this? Can I do this? It's a while since I've done this. It's a while since I've done the whiteboard stuff. Okay, so can I still do it, I wonder? Alright, let's give it a go. I'm going to have to lean through the tripod again, so I'm probably going to have to... Oh, come on, don't play up with the focus. Alright, I'll do a bit of a doodle and see how it looks. So I'll start off with the FET. So the FET... like that. There's the gate. Off like that. Rusty at drawing FETs. How's that look? It doesn't look bad actually. It's a little bit high. But anyway, so that will go to the... that's in series with the tube. At the moment I'll just show it drawn in series with the lamp. So there's the lamp filament, comes down to the drain. On the input, on the gate there, got a couple of resistors like that. This goes down to the negative rail. That's a positive. How does that look? Yeah, so far so good. I don't have a sponge actually, otherwise I'd move that down a little bit. But anyway, so what's happening is that goes to... that's the negative rail. So then I've got plus there, 12 volts, comes in, goes through a pot, and that was the that's the bias pot there I was adjusting. As I was adjusting that, so this lamp was getting brighter and darker, because what I'm doing is, you know, I'm turning the I'm adjusting the conductivity of the FET. So on the real thing, that's decoupled. That's decoupled. Get rid of the RF. That point there is where I had the red wire. The red wire comes off like that, goes down there, and there's that's decoupled as well. The chassis there, like that. Now the activation relay, common goes to 0 volts or chassis. That goes to chassis. Actually, on the real thing, that's this point here. The source here for the FET is separated from this chassis line by 2 back-to-back diodes, clamping diodes, just for the metering. But effectively, it's not going to make any difference with regard to this, so I'll leave that out just to keep it simple. And what is happening is, that's the normally closed contact, that's the normally open contact, that's the common. So when the PTT is pressed, this relay activates. Oh, actually, let's draw in the 2 switching relays. So there'll be the input relay coil, the output relay coil. So what happens is, this relay, this is the activation relay, so when I press the PTT, this relay kicks over. So this goes open circuit, this conducts, turns the lamp on, the tube on in the real amplifier. That kicks over to there, energizes the input and output relays. So the valve conducts, the input and output relays switch the amplifier in. When I release the PTT, this drops back to this position and shuts the valve off. This turns the input and output relays off, and shuts the valve off by turning the FET in the cathode of the tube off. Now, is there any room there to actually draw the tube? So in the real thing, so say this is a little bit high here, but I'll give it a go anyway. It might be all right. In the real thing, that would go to part of a bifilar choke, like that. Be another one like that. That would go off to the AC heater supply. I'll have to see if that's still in shot. That would then go to the tube cathode filament, like that. There's the grid going to ground, there's the anode circuit there, RF comes in there like that. That will be decoupled there and there as well. So that's in the real thing how it will be connected. So you can see that by adjusting this pot, this will adjust this cathode bias here, which is effectively adjusting this negative bias on the grid here. This is how this will turn. This will shut the valve off when there's when the PTT is not pressed. This line here goes to 0 volts, and this becomes an open circuit, shuts the valve off. So hopefully that makes sense. But that's what I've got in mind for it anyway. I'll let you know. I'll let you know how it goes. As always, hope you found that interesting, and I'll catch you next time.